Let me introduce Megan Hayes. Megan Hayes is an Australian researcher, writer, and artist currently based on Kalapuya lands, where she is a PhD candidate in the University of Oregon's Environmental Sciences Studies and Policy program. Her research interests crisscross science studies, the blue humanities, and artistic research. Fields informed by undergraduate studies in photography and situated media at the University of Technology, Sydney, and a research master's in cultural analysis from the University of Amsterdam. Megan's PhD project, How to Love an Oyster: Chemistry, Sensibility, and Attachment, studies oyster human relationships and the worlds those relations sustain. Here you go, Megan.
Thank you. Can you hear me through the microphone? Sort of.
Maybe get it closer.
Here?
There's also a volume.
Oh. Anything?
Do you want the volume up? I can do it on the screen.
Oh. Can you hear me okay without it? No? Okay, yeah, maybe volume would be helpful. Thank you.
Here. It used to be. This is a new thing for me.
Or is it just
Oh
this?
yeah, there. Yeah.
Oh.
Yeah. Lapel mic.
Oh, sweet. Thank
It
you.
might be that one.
Is that better?
Yeah, I did a little bit.
Yeah? Is that okay, Stacey? Okay. Thank you.
Just barely.
Okay. I will project. So I'd like to begin just by framing my paper briefly because it's much more grounded in theory than design. And that's also why I'll be reading it fairly closely. I wrote this paper in the wake of a long-standing interest in shifting ocean chemistry, but I'm definitely not a scientist. I belong in, or maybe to, the environmental humanities, and I think about science largely through feminist theory. And in large part, this paper is a documentation of my navigation between seemingly incommensurate forms of knowledge. My interest in ocean chemistry was sparked early on by the ideas in an essay written by Dr. Stacey Alaimo called Your Shell on Acid, in which ocean acidification becomes a site of altered consciousness, an altered state of consciousness necessary for any adequate comprehension of planetary climate change. And then after moving to Oregon a couple of years ago, my interest became much more grounded. And I spent a lot of time getting to know relationships between chemistry and place, speaking with artists and farmers and scientists, sneaking into graduate seminars and WhatsApp groups on ocean biogeochemistry, and working on oyster farms. I hope that the interdisciplinarity of my work sparks your interest in relation to the themes of this conference. And I think there are lots of points of entry, such as the relationship between form and process, abstraction and method, aesthetic membranes between knowing, doing, and being. And I think most significantly for me is resisting hegemonic paradigms of thought by holding space for the pluralities in any assumed we. And so with that, I will begin. Ocean acidification is pink. It is pink in the morning at the oyster hatchery when larvae lie motionless at the bottom of their tank. Pinkness in this moment indexes empty bellies, bare oyster tissue, hungry and exposed. The baby oyster bellies are pink and empty because the chemistry of their watery surround was not conducive to shell formation overnight. Magallana gigas, commonly known as Pacific oysters, have a genetic demand to go from having no shell whatsoever to a fully formed shell within several hours of hatch. This whirlwind creation of a solid, rock-like exterior as if from thin air, which is to say, drawn from the ingredients of their liquid medium, is the oyster's first and only priority once they burst into life. The larvae must work to build shell before growing swimming appendages, before even feeding. If they fail to do this, their energy reserves will be spent, and the larvae will find themselves unable to progress to the next life stage. And so, when bad water is drawn into the hatcheries along the US Pacific Northwest coastline from particularly acidic ocean conditions, the hatchery folks will come out the next morning and find their larvae pink, bellies devoid of brown pigment from the diatoms they should have been eating. Instead, the oysters will have been starving themselves as they lay waiting for shell. Ocean acidification smells like a conference room at 3 in the afternoon. It is slightly sour, recalling the lip of a San Pellegrino. It is the smell of carbon dioxide poisoning. The aromatics of CO2, carbon dioxide, at the ocean's edge are subtle and rendered sensible by way of contrast to the smell of less acidic waters. A person's apprehension of such subtle CO2 gradations thus requires strong attunement to the scent of a particular shoreline. In contrast, many uninitiated bodies will likely sense the carbonic saturation of a conference room afternoon by the intensity of groggy delirium. The delirium is hypercapnia, that same condition fish are plunged into in CO2 saturated waters. Back at the Oregon coast, ocean acidification feels like the north wind on the skin. For those calibrated to the currents of the area, water chemistry reverberates in the north wind. Together with local inputs from nutrient-rich river water, seasonal upwelling of acidified waters, deep ocean waters, onto the continental shelf make the Oregon coast one of the most acidic oceanic regions on the planet. When oyster hatchery production collapsed in 2007, Oregon became one of the first places in the world to observe the spectacular impacts of contemporary ocean acidification. As acidification and hypoxia events continue to intensify, Oregon's iconic fisheries and the coastal communities that depend upon them, as well as the ecosystems rippling into and out of them, will become increasingly vulnerable. This paper unfolds between bodies immersed in these environments and the knowledges produced within them. Beginning with these sensory vignettes shared with me by scientists studying ocean acidification on the Oregon coast, it is oriented by the repetition of those scientists' resistance to naming that sensing and sense-making as knowledge. Seeking deviation from the urge to split the knower from the known, I want to play here in this talk with the promises of litmus, the dye which gives a strip of litmus paper its hue, and the metaphorical litmus test its material ground. Akin to how the color of a litmus strip expresses the chemistry of the liquid it has touched, my argument takes seriously the accumulated impressions of encounter as environments archived as knowledge. These subjective fragments held together by relationships between stories, bodies, places, and time form knowledge not reliant on abstraction, but on being caught up in a mess of relation, in opposition to the estrangement of people from places increasingly squeezed out of shape. Ocean acidification is a multi-scalar dissolve of shells, lives, livelihoods, and relations entangled between elements and bodies, both human and more than. Acidification events have occurred throughout Earth's history, but those coursing through our contemporary are different. They archive 2 centuries worth of carbonic detritus from a planet carved out as a modernist grid for colonial empire and global capital. In the wake of this fossil-fueled momentum, the chemistry of the world's oceans is changing at rates unparalleled in the past million years. Thanks to the ocean acting as a planetary carbon sponge, its surface waters continue to absorb almost 30% of all fossil fuel CO2, equating to about 1 million tons per hour. As a consequence, the average pH of the ocean's surface waters has dropped from 8.2 to 8.1 since the beginning of the industrial era. Given the logarithmic nature of pH, this drop represents a 25% increase in acidity over the past two centuries, and it is this rate of increase in particular, the intense speed of the pH fluctuation, that is most cause for concern, as it means the usual buffering mechanisms of the hydrosphere do not have the time they need to maintain steady ocean conditions. According to the Intergovernmental Panel on Climate Change, the IPCC, the continued release of carbon dioxide at current rates will cause ocean pH to drop another 120% by the end of this century, to a pH of 7.8 or 7.7, a more acidic ocean than any seen for at least the last 20 million years. To put that into context, it's predicted that at a pH of 7.7, coral reef development will cease. It's not insignificant to this story that the oysters of Oregon's present-day coastal ecosystems traveled from distant Pacific shores. The Oregon Department of Fish and Wildlife website explains that there are now 2 species of oysters in Oregon estuaries: the commercially grown Pacific oyster, Magallana gigas, and the native Olympia oyster, Ostrea lurida. Neither species is legal for recreational harvest, the DFW advises, because native oyster populations are protected to encourage their recovery. And since Pacific oysters are only commercially grown, they are private property. M. gigas arrived on the west coast of the US in 1919 after having crossed the Pacific on a steamship bound from Japan, a journey that had been conceived of by a pair of oyster farmers, J. Emi Tsukimato and Joe Miyagi. These 2 young men had grown up in Olympia, Washington, working the local oyster beds throughout their school years. And while this isn't a photograph of those 2 men, it's a photograph of the construction of the oyster bed dikes at the Brenner Oyster Company in Olympia in 1910, so it's the place and time in which they were working. They developed a plan to import a robust oyster seed from their first home of Japan in the hopes that it would establish a thriving population. This transplantation was only necessary due to the exploitation and pollution that had decimated the Olympia oyster in the wake of waves of settlers drawn west by colonial dreams throughout the 19th century. Their plan worked, and M. gigas flourished in its new home, but the business success this brought Tsukimato and Miyagi didn't last long. In 1921, the Alien Land Law was passed in Washington, and it became illegal for Japanese residents to lease or own land. The pair were forced out of their business, and the oyster farm was taken over by white farmers. The Pacific Northwest coastline has felt pulses of acidification, as well as pulses of racist coloniality, and fluctuations of oyster populations are tethered to both. Put another way, the ebb and flow of oysters is one manifestation of the ways in which climate change and colonialism are inextricably linked. The tilting of bivalve mollusk numbers away from wild communities and toward commercial, privatized production occurred in tandem with multiple severings of relations between beings and place. The relationships between Tsukimato and Miyagi, the oysters they invited to the Pacific Northwest, and the shoreline their farm was situated on were severed. On another scale of relation are the tribal nations who have stewarded shellfish on the Pacific Northwest region, shellfish of the Pacific Northwest region, such as the once abundant Olympia oyster for generations. The acidification that now threatens Oregon's Pacific oyster can be seen as a reiteration of that severing of relation. As Kyle Powys White writes, climate destabilization repeats patterns of industrial settler strategies and tactics that are very familiar to Indigenous experiences with and memories of other kinds of anthropogenic environmental change. Ocean acidification is a complex problem, one that has troubled science for decades, but most acutely since the early 2000s, when it became a coherent field of study and a research funding magnet. The term ocean acidification encompasses a series of intersecting chemical processes unfolding on massive spatio-temporal scales, all of which makes it difficult to contain or abstract in the lab or the field, let alone apprehend in immediate sense experience. Expressing as incremental and accretive ecological corrosion, ocean acidification is sensed in its movements through marine bodies and technologies submerged in their medium. None of this necessarily makes acidification a uniquely difficult problem for science, though. But where acidification does become a remarkably difficult problem is in its resistance to cultural translation. In other words, despite its existing and looming ecological effects, ocean acidification can appear to be unthinkable as proper knowledge beyond the terms of dominant science, which for brevity's sake, I'll refer to simply as science and its practitioners, scientists. But to be clear, I'm using the phrase dominant science because, unlike alternative terms such as Western science, dominant foregrounds and underscores power relations, emphasizing how one cultural tradition of science can erase or deem illegitimate other ways of knowing, doing, and being. And here I'm drawing on the work of anti-colonial science researcher Max Liboiron and their book, Pollution is Colonialism. Their brilliant book, I should say. In 1920, mathematician turned philosopher Alfred North Whitehead named a critical assumption of that science as the bifurcation of nature. Corresponding to John Locke's distinction between primary qualities, those measurable and objective qualities considered inherent to the perceived object, like size and shape, and secondary qualities, which are considered to reside in the percipient subject rather than in matter itself, for instance, sweetness and warmth. The bifurcation of nature insists upon an environment made up of isolated bits of matter, moving through space. In this formulation, sensory elements such as colours, sounds, and smells are mere psychic additions, or effluent, to an influent objective material nature. But, as Whitehead explains, nature encompasses everything, including experience. You may know a sunset, for instance, through your cognitive understanding of atmospheric refraction, sunset as scientific object, and also as a dazzling shock of pink sky, sunset as subjective experience. Similarly, one can know fire, flood, and the brilliant flash of white bleaching coral through both measurable and objective causes, as well as through apparent perceptible qualities. Acidification, however, remains obstinately dilute to the sense awareness of most people. The anecdotal sensory vignettes with which this paper opens relays bodily apprehension of acidification, and they first came into view for me when local scientists shared descriptions of their situatedness. That scientific situatedness grounds an apprehension through abstraction and immersion at one and the same time. Scientific rationalism does not recognize immeasurable sensory awareness situated in the body or social contexts as an object of proper knowledge. This is because such awareness steps beyond the threshold of what we can know as demarcated by experimental sciences, and what we can know is the defining condition of rationality by which the enlightened human subject must abide. There is, of course, a particular way in which scientists are supposed to orient in relation to their objects of inquiry, grounded precisely in rational, disembodied practice that forms knowledge wrung dry from the messy, noisy moisture of subjectivity. In their historicization of objectivity and the scientific selves that it has subtended, Lorraine Daston and Peter Gallison describe subjectivity as, simultaneously, objectivity's archenemy and its reason for being. It is within gestures, techniques, habits, temperament ingrained by training and daily repetition that scientific character and conduct is described and prescribed. Practices of training the senses in scientific observation, keeping lab notebooks, drawing specimens, habitually monitoring one's own beliefs and hypotheses, quieting the will and channeling the attention, fashion an ideal scientific self necessarily alienated from bodily rawness. It is through the repetitive performance of these bodily and psychic actions that objectivity comes into being. But to know through the wind, through attunement to the dynamics of place, through the sensorial shock of an encounter with all too pink flesh, is to know by way of fully embodied aesthetics, calling upon the Greek root of the word aesthesis. Embodied knowledge, Astrudanimanis writes, whilst often denigrated and disavowed within the modern colonial episteme, confirms that Western scientific validity comprises only one kind of knowing. Manifest through poetics, aesthetics, and other bodily attunements, sensuous knowledge is open to alternative modes of relation. Such knowledge is founded on different epistemic virtues than those which give validity to the abstractive operations of so-called objectivity, but it is knowledge nonetheless. Perhaps most importantly, it is knowledge that recognizes itself as partial. When the scientific object of a sunset appears to be more real, more concrete than the sensory experience of the sunset, it's because it has been stripped from its context. It has been abstracted and then mistakenly understood to exist as a concrete thing in isolation. Whitehead describes this as akin to believing that the grin of a cat can really exist in isolation from the cat's face. You can only imagine this to be true, though, because you can conceive of the grin in isolation. It's important to remember that the abstractive procedure itself isn't necessarily a problem. Abstractions are necessary to hold particularities of worlds in thought. A problem only arises when the abstractions upon which science relies are not critically acknowledged, because by extension, the exclusion of everything else that is entangled, but which science has deemed irrelevant, is then also left unacknowledged. This exposes science to the dangers of unimaginative empiricism, which defends its own assumptions without engaging with possible alternatives. When I ask scientists about their sensorial bodily relation to ocean acidification, as I've done over Zoom throughout the early stages of my PhD, I want to know two things. I'm curious what sorts of knowledges are held in their body, accumulated and imprinted through durations of experience and encounter, but I also want to notice whether such a line of inquiry has traction with them, and watch for any resistance that might arise. Resistance is interesting to me because it might demarcate the edges of a presupposed common sense, a common sense that needs the body to become unwelded from its surround in order to create recognizable objects of knowledge. I enter into conversations with these scientists from a very different axis of orientation to the objects of study lying between us. My research questions and methods are oriented not so much by practices of quantification and systematization, but instead by cultural analyses of science, allied with anti-oppressive political projects of feminism, queerness, and environmental justice. As a result, these conversations are steeped in a certain degree of incommensurability, considering how they straddle humanistic and scientific inquiry. Every time my interlocutors have joined me in entertaining sensorial knowing, I see them generously teeter on the edge of sense, offering an account of acidification on the skin or in the nose before becoming disoriented and pulling themselves back. I suspect I'm witnessing the disorientation Sarah Ahmed describes as the awareness of our own contingency and the horror with which it fills us. This disorientation throws the world up, or conversely, throws the body from its ground. The body might be reoriented from such an unsettling feeling if that hand that reaches out finds something to steady an action. It is to objectivity that the steadying hand returns them. In resistance to the modernist commitments that have narrowed the kinds of knowledge that count as proper, I'm interested in the ways ocean chemistry becomes an agent rearing, pushing against the limits of what counts as thinkable or knowable in dominant fields of the sensible. Apprehension of acidification beyond the terms of science figures an ocean asking to be known via the fullness of bodily sensation, a fullness that pulses in relation to those beings entangled with particular shorelines, constituting a sensorial ensemble. And the oyster is a particularly notable companion with whom to be forming such an ensemble. According to Carl Steele, oysters have lived for a long time as border creatures, historically taken up for use when a writer wants to argue about the ethical inconsiderability of animals, or to imagine animal life at its most minimal, or to determine the absolute limits of life. Indeed, that Cartesian divide that jettisons mind from body and man from animal originally pivots, in fact, around the oyster. In November of 1646, René Descartes wrote a letter to Margaret Cavendish, Duchess of Newcastle, in which he argued that any belief in animals having the capacity for human-like thought, and thus belief in the animal capacity to possess an immortal soul, must extend to all animals, oysters included. But, according to Descartes, the latter are simply too imperfect for this to be credible. Remarkably, the imperfection of the oyster thus becomes grounds for the Cartesian designation of all animals as irrational, soulless automatons. Expanding our historical scope half a century prior to Descartes' birth helps underline the monstrous trajectory of his conclusion. In the middle of the 16th century, an important precursor to Cartesian thought can be found in the Valladolid debate between Dominican friar and Bishop of Chiapas, Bartolomé de las Casas, and monarchical humanist scholar Juan Ginés de Sepulveda. Las Casas and Sepulveda were supposed to clarify the nature of indigenous humanity and determine the legality of waging war against New World populations to bring them under Spanish rule and instruct them in the Christian faith. Whilst neither side won the debate, it became a foundational moment in defining the edges of, and thus deciding who would be granted the status of, human in the growing matrix of coloniality, based on who would be recognized as possessing a soul. The recognition of shared sense-making practices with an oyster, then, arrives as a form of resistance to the tendrils of that history, and as a potent reconfiguration of the human subject who knows. Let's consider this on the terms through which ocean acidification is most often represented and communicated colloquially: pH. pH is a scientific measurement that permeates pop culture in curious ways. My biogeochemistry professor used to say that every political science professor with a hot tub thinks they understand pH, but likely they understand it about as much as those people trying to manipulate their body pH to develop immunity to COVID-19. A logarithmic scale indicating the acidity or alkalinity of a substance, pH is rendered visible, which is to say available to the senses, using the spectrum between the red and blue ends of a strip of litmus paper. In the mouth, this spectrum is at one extreme the scrunch of a face to the sour bite of a lemon, and at the other the sharp pungency of bitter gourd. Beyond the immediate sensory apprehension of acid base in the mouth, acidity and alkalinity are complex scientific measurements. Even more challenging than the fact that pH is poorly understood by non-scientists is that it is a nearly useless concept for thinking about the narrow range of chemistry within which the ocean is actually moving. What's more, the variables that shellfish are responding to likely are not even pH, but other correlated yet distinct processes. The pink oyster larvae, for instance, are responding to the saturation state, or omega, which shifts in tandem with the drop in pH. The word litmus dates back to the late Middle Ages and has its etymological roots in the Old Norse lit mossi, from dye and moss, from the discovery that an organic compound obtained from lichen turns red in acid solutions and blue in alkaline solutions, making it a reliable acid-base indicator. I want to claim that litmus, then, is a kind of sensitivity, a capacity to sense and make sense that happens on a spectrum between bodies, animal, vegetable, and mineral. This betweenness is amplified when the specificity of lichen is taken into account. Whilst moss has just historically been used to name both organisms, the two are quite distinct. Mosses are multicellular plants with leaflets made of photosynthetic cells, whereas lichens are complex organisms formed by a symbiotic relationship between fungus and algae, thus blurring the definition of what it means to be an individual. Orienting to body as litmus feels like orienting to cautious, relational, situated exploration of distributed subjectivities. It feels like collaborative sensing practices in which subjects are expressions of environmental experience. In such a formulation, environments are not things out there, and subjects are not the starting point of sense-making activities. Body as litmus offers a way of grasping one's own sensory experience as a meaningful bioindicator of environments which are the possibilities for subjects to make sense in the first place. Body as litmus is not some kind of pronouncement that scientists are wrong. This talk is saturated with, and owes a debt of gratitude to, the labour, time, and generosity of so many scientists. And my own apprehension of ocean acidification is greatly mediated by biogeochemical findings. But it is mediated too by the water that lubricates my eyes and hydrates my brain, and by the countless organisms immersed in and affected by slowly acidifying waters, and by all of those who keep on teaching me to comprehend otherwise to abstraction. Body as litmus, then, is a recognition of knowledge as a more than rational collaboration. It's a moment in which an ensemble of knowers interface in a flash of feeling and the slippage of membranes. It's an acknowledgement of the delimiting impulse to carve out the world in languages that reiterate a coloniality of knowledge, and an invitation to elevate collective knowing that happens in between. After all, litmus is not a matter of precise coordinates, but of spectra. Red or blue or pink catches you, pulling your body into calibration through a fuzzy indicator extracted from an assemblage of beings. The process yields a suggestive hue rather than numerical value, its findings residing in the lag time between aesthetic knowledge gleaned through sedimented stories, intuitions, and sustained noticing, and that which is made concrete through abstraction and scientific consensus. On the terms of both physics and philosophy, colour is not an inherent property of matter, but rather a matter of perception, related to an object's light absorption, reflection, emission spectra, and interference. Perceived by most humans through the eye's cone cells, the critical point here is the way colour manifests in a relational field. Rather than colour's reliance on visuality, litmus in a more metaphorical key can become synesthetic, with senses overlapping or cross-mapping in the myriad interchanges between bodies and habitats. Focalized through litmus, the earth is both legible and elusive, traced through bodily membranes to archive the aesthetic shift of encounter, coloring the wake of immersion. Thank you.